Hello everyone, I welcome all of you to the YouTube channel of Ashok Vidyalaya and Junior College Science and in the webinar of Computer Science Paper 2, Chapter 1 Microprocessor 8085. Friends, we have already started our session and we have introduced ourselves by 8085 microprocessor evaluation. What are different evaluations we have seen? We have seen the first generation, second generation, third generation, up to the fifth generation, how the microprocessor has been evolved and how the generations have been developed from 4-bit to up to 16-bit, 32-bit microprocessor, right guys? Today we are going to see the pin diagram of 8085 microprocessor. Moving ahead, the microprocessor 8085 have these following features. The total number of pins of microprocessor 8085 are 40. Total number of pins are 40. There are address bus, data bus, and control bus. The address bus is of 16-bit. That is 64K bytes can be addressed. As all of you know that computer understands only binary language, that is 0 and 1. So everything is in the power of 2. So if you say the 16-bit, 2 raised to 16 will be equal to 16 kilobytes. So total memory locations that can be accessed by this particular microprocessor chip 8085 is 64K byte. So if you see how many locations will be there of a memory which can be addressed by this microprocessor, so such type of there will be 64K bytes K bytes of memory can be accessed. The next feature is method of using address bus. Here we see that the method is a multiplexed bus. We will see in detail what do you mean by multiplexed. So what is the method of using address bus? Is a multiplex bus. The method of use for external memory or internal or external memory or IO device is IO mapped IO. And total instruction set, the commands which can be given to 8085 are 74 instructions. So this is in brief. If anybody asks you that what do you know about 8085, then these are in the nutshells the features of 8085 microprocessor, which is in the terms of number of pins, number of instructions, data bus, address bus, and the methodology of addressing the bus. So let's revise this once again and see the features of 8085 microprocessor. The total number of pins 40. The data bus 8 bits. Address bus 16 bits. Method of using the address bus multiplex bus. Method of use external memory or IO device, it's IO mapped IO type. And instruction set is 74 instructions. Total there are 74 instructions in the assembly language which can be given to this 8085 microprocessor. Okay friends, now once we see this feature, let's go ahead and see the functional pin diagram of 8085. If you see here, this is the block diagram or this is the pin diagram of 8085 microprocessor. I will just enhance this so that you will be able to see in detail. So total there are 40 pins, 20 pins here and 20 pins here. If you see very clearly, or if you see it, the numbering starts with here 1 to 20 and here 21 to 40. Total there are how many pins we have seen? 40 pins. Now let's see what are these different pins and the functions of these different pins. In your textbook on the page on the page 193, the details of each and every pin is given. We will see today the main pins and its function. I have just made the colors differently to understand and to identify the different types of pins. Let me again slightly change this size. Okay, let me check whether it fits the screen or not. Okay, so let's see, the first one is the address bus. As you see here, the name is given as AD0 to AD7. So these green AD0 to AD7 are used as a multiplexed bus. What do you mean by multiplex bus? It means that the same pins can be used for two different options or two different functions. Therefore, the name indicates it is AD0, means it is used as an address or it can be also used as a data. So this AD0 to AD7 means is a multiplexed bus. Multiplexed means the same thing can be used for the two different options. Whenever you want to put address, the 8 bits will be given on this particular 8 lines. At that time, the content on this particular pins will be address. And when you want to give data, the same lines at that time will be used as a data for transferring the data. So this A0 to A8 are named as AD0 to AD7 because they are used for both address or a data. As you know that a data is of 8 bit and address will be of 16 bits. So whenever you want to put a data, the data will be transferred from this particular pin AD0 to AD7. And when you want an address of for a particular memory location, then how you can give these 16 bits now? For that, what is required? Again, another 8 lines will be required if these pins are made dedicated only for the data. Are you getting this? If suppose we have only these pins dedicated for data, then what will happen? For 16 bits of an address of a memory, we have to give another 8 pins. But now this 8085 has made us suitable to use the same lines AD0 to AD7 for both address as well as for the memory, and the same lines are used for the address or the memory. Therefore, it is address or the data, that it is called as multiplexed bus. Now remaining 8 bits will be given on A8 to A15. So which are the address, which are the address lines or which is the address bus? This AD0 to AD7 and A8 to A15. AD0, always in microprocessor the index starts with 0. So 0 to 15. How many numbers are there between 0 to 15? If you count it, then it will be total 16. Are you getting this? Therefore, to carry the memory location of 16 bits address, this address bus is used with AD0 to AD7 and AD8 to AD15. Now, the one thing it should be very clear is this particular memory location has its address as 16 bit, but the data stored will be of 8 bits. Data stored will be of 8 bit, but the address of this memory location will be of 16 bit. This needs to be considered. Let's see. I will repeat again. Suppose this is a house, and in this house there are 8 people. How many people can live in this particular house? 8. Now to identify this particular house, there must be some name given. That particular name will be given of 16 bits. Of 16 bits. But how many people can live in this house? 8 bits. Therefore, the content in this particular location, memory location, 1, 2, 3, 4, 5, 6, 7, and 8. So D0 to D7 will be the content stored in this memory location, and which is nothing but a data. And where the data is stored, that will be given by 16 bits. So data will be 8 bits and the memory location or its address will be of 16 bits. And therefore we require 16 memory locations. Therefore we require 16 address lines to find out first the memory location, and second 8 lines to put a data for a particular memory location. So remember guys, whenever there is a memory location, we require 16 lines. Whenever we want to put data, we require 8 lines. Clear? I hope this is clear to you. Moving ahead, we have cleared this. Just put in chat box, is this clear to you? Yeah, nice. Let's move to the next pin, that is VCC and VSS. See, this is VCC and this is VSS. As all of you know, this is nothing but integrated circuit, IC, electronic circuit. This chip requires some power supply of 5 volt plus or minus 5 volt. This, see, this not minus 5 volt, plus 5 volt and a ground. So this particular 5 volt supply and a ground, that will be power will be given by to this chip from this particular pins, that is VCC and VSS. There is a clock, that is a frequency. That particular frequency circuit is at this X1 and X2. Now let's see what is the use of the RD bar and WR bar pins. So where is the RD bar? That is, as name indicates, bar means what? How it is written? It is written like this: R, D, and bar. And we have to read it as RD and bar. WR and bar. So we have to just keep a horizontal line above this. Correct? So even if I have written here as RD into bracket bar and WR into bracket bar, it is all actually written as RD and bar, the horizontal line above the word. So what is this RD bar? It is active low pins. Active low pins means the status, the output of this particular pin gets complemented. Therefore, it is bar. Bar means complemented. So it is active low. Therefore, when we want something to get set, So when RD bar is low, the selected memory or IO is to be read and the data is available for the data transfer. So if you see a memory, what is use of memory? The use of memory is to store data, nothing else. It is a dump, that is, it will use to store the data. Now, when we want to store the data, the microprocessor, this microprocessor and this memory will do two things. One, from microprocessor, the data can be stored, and from memory, the data can be read. So when it is from memory, that is when we say come, microprocessor is saying come, it means we are reading the data. And when we are saying that go, then microprocessor is storing the data. So memory is only to put the data. Now, whether to read that particular data or whether to write into that particular memory, that will be given by this particular option. And that option, which operation this microprocessor is going to do, that operation is given by RD bar and WR bar. Remember, RD bar. So if you say only RD, there is a complement above this. So if RD is 0, the complement of 0 is 1. Now, when RD bar is low, that is RD bar is low, the selected memory or IO is used to read the data. So what should be the status of this RD bar? The status of RD bar is it should low. When it is low, it indicates RD bar is low. It indicates that the memory or IO is to be read and data is available for the data transfer. When WR bar, that is write, is low, that is data on the data bus is to be written into the selected memory location. Let's see, this is very, very important. When this microprocessor wants to read something from the memory, then this particular pin will set low, that is RD bar. Now RD bar is low means what? The memory, we want to read the memory. And when we want to read the memory, the data is available for the data transfer, for the reading. And when it is WR bar, when this write, WR means write. So when this WR bar is low, the data on the data bus is to be written into the selected memory location. So see the wordings. When RD bar is low, the selected memory or IO, IO means input output device. You can say selected memory is to be read. So the memory is to be read and data is available for the data transfer on the data bus. And when the WR bar is low, means we are going to write something into the memory, then data which is already available on the data bus is written into the selected memory location. So guys, have you cleared about this cycle? This will come when we see the machine cycle, instruction cycle, and the machine cycle. So here, this is the read operation and this is the write operation. When we want to read the case, when we want to read the data, then the memory location will be selected and the available memory location will take the data, fetch the data onto the data bus. And when write is done, then whatever to be written is onto the data bus. So data bus is to be written. Data or data bus is to be written into the selected memory. And here, whatever the data for which the memory is selected, that should be made available onto the data bus. See the difference between the wording. Data is available. The IO is read and data is available. And here, data is to be written. So when we want to do the write function, this WR bar should be low. And when we want to read operation, the WR bar will be low. This indicates whether we want to write or whether we want to, which operation microprocessor, we means microprocessor, which operation microprocessor wants to perform, whether it is a read operation or whether it is a write operation. Let's see where are these read and write pins. These are the addresses and the data. These are the X1, X2 are the clocks. Now where are read and write? Can you find out where are read and write? Can you put it in the checkbox? See 32. Yes. Just tell me in the checkbox which pin number is the read RD bar. See here 32 and 33. So RD bar, that is read, and 32 is read bar, RD bar, 33 is the write bar. So when this RD bar is low, it means that microprocessor wants to read the data from a particular memory. Read the data means like this. Data is already stored in the memory. Microprocessor wants to read the data. And when WR bar is low, it means microprocessor wants to write the data. Correct? So microprocessor does the process. After processing or processing gets completed, the result has to be stored somewhere. Microprocessor cannot store anything. Microprocessor will pass that particular information to a memory. Now this to be given, this should be indicated that microprocessor is writing. That particular operation will be indicated by this RD bar and WR bar. Right, guys? Moving ahead, once we have seen this functional pin diagram, let's move ahead with the another pins, that is reset in bar and reset out bar. These reset pin bars are used, reset in bar, they are used to reset the very important uh, register of 8085, that is program counter. So this pin is used to make the program counter of 8085 for resetting to 0000H. Now what is this 0000H? This is a memory location address. Why this is 0000H? Now friends, remember, whenever we talk in assembly language, we always talk in the hexadecimal number system, that is 0000H. H means hexadecimal number system. So 0 is 0000. This 0 will be 0000. This 0 will be 0000. And this 0 will be 0000. So total how many bits will be there? 4, 4, 4 and 4. Total 16 bits. We have seen that for address, memory address is of how many bits? 16 bits. And how it is represented? It is not represented as 3, 2, 6, 8 like that. It's not in the octal decimal number system. It is in the hexadecimal number system. Hexa means what? 0 to 15, total 16. So we have 0 to 9 and then A, B, C, D, E, F. So if we say, if we want to show 1111 number, then it is given in hexadecimal as F, 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 F. F, 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 F. Are you getting this point? So 1F will be 1111. Second F will be 1111. Now what is 1111? This is a binary. Can you find out what is 1111? This is 2 raised to 0. This is 2 raised to 1. This is 2 raised to 2. And this is 2 raised to 3. Now when it is 1, it means on. So 2 raised to 3. 2 into 2 into 2, which is equal to 2 into 4. 4 into 2, 8. So it is 8. Plus 2 raised to 2. 2 raised to 2 is 4. 8 plus 4, 12. Plus 2 raised to 1, that is 2. Plus 2. And anything raised to 0 is 1. Add it. 2 raised to 8 plus 4, 12 plus 2, 14 plus 1, 15. So when we say F in hexadecimal is nothing but 15, which is given by 1111 in the decimal number system. Clear, guys? So this reset in is a very special function. Reset in bar, again it's a complementary. So reset in bar is used for resetting of program counter. We are going to see in the next session what is the meaning of this program counter and this register is used for what. And that program counter's address is reset, is used to reset the program by peripherals. Because for this microprocessor, the connection will be from 2 points. One is microprocessor gets connected to the memory, or microprocessor gets connected to the input output peripherals. That is keyboard, screen, input output peripherals. There is, if you observe, there is no connection directly between memory and input output. Everything will be from microprocessor reads and write the information from memory and sends it to the IO. It takes it from the input output and sends it to the memory. Then reset out. Reset out is a what? The shakehand of reset in. So someone has said that reset this program counter to 000H. Then microprocessor acknowledges it. Yes, I have made this program counter reset for your information. So this is what, hey, hello. Someone has saying, hey, hello, how are you? Then you are also saying, hey, hi, I am fine. This is similar to reset in and reset out pin. The next are the interrupts. See, these are the interrupts. Trap, 7.5, 6.5, 5.5, and INTR. 1, 2, 3, 4, 5. There are basically 5 interrupts, 5 interrupt pins in the microprocessor. Now, what is this interrupt? This interrupt is very, very simple concept. There are two types of interrupts, software interrupt and hardware interrupt. Now, these are the interrupt pins. The concept of interrupt pin is basically the signal which interrupts microprocessor. Now, microprocessor is always busy in doing some work. Correct? Microprocessor is always doing some work. Now he will not check uh, everywhere where the data has come or not. Now when the peripherals wants to enter, say input peripheral wants to give a signal to the microprocessor, then microprocessor will not every time ask that are you ready, are you sending me the data or not, because microprocessor has to do n number of work. So microprocessor keeps on working the information instruction. Now when we press, say suppose the keyboard, or when we press give the signal from the keyboard, then microprocessor may or may not be free at that time when we press a key from a keyboard. Now we should knock the interrupt. We should interrupt the microprocessor that, hey, hello, talk. I am here. Please open the door. So in that case, what you will do? You will stop or you will complete the work which is in your hand. Then instead of going ahead with the continuing the work, you will go to the door, you will receive the people, and then again you will resume with your work. This is what the concept of interrupt is. Let me explain you in a very simple way that suppose you are studying here in your room. This is your house and this is a door. Now, if I want to enter in your house and you are studying, then what I am doing, I am putting a signal to you by putting a bell. This is what, see, when you are studying here, every 5 seconds, after every 5 seconds, are you going to see that someone has come or not? Are you going to see that someone has come or not? No. Then you cannot do the study. So what you will do, you will go on doing the study. Now, if I want to tell you that, hey, I am here, please open the door, I will send an interrupt to you. I am interrupting you what you are doing as a study. So as soon as I give a bell, then what you will do, suppose you are studying a lesson and it has completed up to half the way. What you will do, you will remember that yes, I have completed up to this. You will go to the door, you will open it, whatever the communication which I want to do, you will do it. I will do it with you, and again you come back and resume. And will you start again reading from the one? Obviously not. What you will do, you will start reading again the next one. This is the concept of interrupt. Similarly, if the input devices and output devices or peripherals, if they want to interact with a microprocessor, then they first tell that to the microprocessor that, hey, I am here. So they will interrupt the microprocessor so that microprocessor will complete its process which is in hand, and instead of continuing the next one, microprocessor will take your request which is on the interrupt and then will continue with their regular or existing flow. This is what the concept of interrupt is. Friends, have you understood this interrupt concept? This is the same way with which you will interrupted when you are doing a study. So microprocessor means you are doing the study, and peripherals means someone has come to come for discussion, that is a peripheral. Clear? Okay. Now moving ahead. So this is RD bar, then reset, interrupt. SID and SOD are used for serial data communication. There are many devices which require this communication, parallel communication or serial communication for the peripherals. So to do this communication, the SID1 and SOD are used. So these are the pins used for SID and SOD for the serial communication. Ready. You must have seen this 35 as the ready pin. This ready pin, these are the different pins on which a specific signals will be executed. So specific signals will be there, and it has its some meaning and some meaningful output depending on the signal of a particular pin. Now, what is the use of ready? Used to inform the microprocessor that peripheral device is ready to receive or to send the data. So when the peripheral wants to take a data or peripheral wants to get the data, then before sending or receiving the data, this pin will inform microprocessor that a particular peripheral device is ready to receive data or to send the data. For that, which pin is used? This ready pin is used. Now there is no complement or there is no bar like that, like RD bar, because it works like low active. But here it is ready. So when it is 0, or it may be 0 or it may be 1. Right, guys? Okay. Moving ahead, hold and HLD. Hold input pin is required during direct memory access operation. Direct memory access operation. We are going to see in detail what is direct memory access. But when this direct memory access operation is in process or is required to be done, then this HOLD input pin is used. Where is the HOLD pin? See, this is HOLD and this is HLD. And again, similar to the reset in, reset out. One is the signal, another is the acknowledgement. Similarly, here HOLD is the signal and HLDA is the acknowledgement. So the signal informs microprocessor that another device requires to use the address and the data bus. So here this address and data bus will be used by the microprocessor. Correct? Now, if suppose some another device wants to use that, then microprocessor needs to inform that this peripheral is going to use my memory, that is address and a data bus. Correct? And for that, this HOLD is used. HLDA is the acknowledgement. It is the acknowledgement that yes, I have received the signal HOLD. It's a handshake. Correct? All right. Moving ahead. Now let's see. So these are the important, yes. So these are the important pins that are used in 8085 microprocessor. Now quickly let's see what is multiplexed bus. Now when we say multiplexed, obviously it is what? This AD0 to AD7. The same lines used for the two. One is address and second is data. What is one? That is AD0, address data 0 to data 7. What is multiplexed? The method of using common 8 lines for both data and address transmission is known as multiplexed bus. When that when it is a data, then the 8 bits of a data will be on AD0 and AD7. And when it is an address, then least significant bits of 8 bits of address will be on AD0 to AD7, and most significant bits will be on AD8 to AD15. Advantage is the number of pins are minimized from 16 to 8. Because if you see that 16 bits to be addressed, every pin will be addressed with the one bit. Then how many bits will be required? 16 bits we have, because memory address is 16. So how many lines we required? 16. But now as it is multiplexed, the 8 lines are used for both. The number of pins are reduced. What is the total number of memory allocations or locations that can be accessed? That we have seen 2 raised to 16 is 16K bytes memory location can be accessed. At a time in a memory, how many bits? 1 byte data is stored. And such how many memory locations can be accessed? 2 raised to 16 memory locations can be accessed. Each memory location can store 8-bit data, that is 1 byte data. So again, remember guys, this is a memory location where the data is stored. That data can be stored only of 8 bits. But to access this memory location, the address which we give, that will be of 16 bit. That is, if you want to store 8, then this is say 8-bit data, binary. To store this 8-bit data, the address of memory location to be given is of 16-bit data. Clear? So this is like this. In this house, how many people can stay? 8. 1, 2, 3, 4, 5, 6, 7, 8. D0 to D7. Now, if you want to find out any one of this particular persons in this house, you have to reach to this house. So this house must have an address. This address is of 16 bits. That is AD0 to AD7 and A8 to A15. So now when you want to read something, or when you want to write something, where to write and from where to read, what you have to give? A memory location address. That address is given with AD0 to AD15. Once the address is given, if it is read, the data which is in this memory location will be put on the address bus, that is will be put on the data bus. Now what is a data bus? Data bus is the same, that is AD0 to AD7. So when it is a data, then it is AD0 to AD7. When it is an address, then it is AD0 to A15. This is called as multiplexing. The meaning of multiplexing is doing the two things with the help of one particular aspect. So I am useful for putting address also. I am useful for putting data also. This is called as multiplexing. Is this clear? Guys, is there any difficulty? Okay. Now let's move and see what is memory mapped IO and IO mapped IO. Now to select a particular input device and output device, particular address is given as a memory location. So for a particular memory if I want to select the peripheral to be attached to this particular microprocessor, then a memory location is given, memory address is given, so that when microprocessor puts that data into that particular memory location, it is equivalent to giving the data to a peripheral. Such particular processing or such a particular method of addressing is called as memory mapped IO. Now, instead of that, if we have a memory and this memory can be used for similar to address and data. If this particular memory location can be used as memory location or can be used as the memory or as the IO, then in that case it is called as IO mapped IO. So here the memory address can be a memory for IO device and not dedicated to the IO device. It can be for memory or it can be for IO. Second is these addresses are not used for memory locations when given for IO. Once it is given for IO, it is dedicated so that it cannot be utilized for different one. While here these address can be used for memory or IO. So same thing can be again used like the address and data bus. Here the memory can be used as a memory or memory can be used as the address for the memory input output device. Then no control signal IO/M bar. See this IO/M bar will define or will control whether it is memory or whether it is a IO. Because again, when we say that one particular thing is there and it will have two inputs, one from this way, one from this way. There must be one controller. That controller will say that, okay, now you wait, you go, or you wait, you go. That is a controller. That is a signal. That signal is IO/M bar. IO/M bar. That is memory. So if the IO/M bar as the same memory address can be for memory location or for IO, control is required and that is done by IO/M bar. With this memory mapped IO, memory space is reduced because if this is a memory space out of which these locations are given as a IO input output device, then actual memory is used only this one for the memory. But while with IO mapped IO, the whole memory can be used as a memory for memory location to store the data, and whenever it is required to store IO, the same will be used for the address for the IO. So it gives the full memory utilization. It gives the reduced memory utilization. This memory mapped IO requires 18-bit address. It can be used with the 8-bit address. Moving ahead. So have you understood this? Please give response on the chat box. Have you understood this? Yes. Okay, that's great. So now when we say IO, along with the IO pin, the read and write operation of a particular memory or IO is done with this combination. There are another two pins. One is S1 and second is S0. So combining these three, it will give the operation for the 8085. See, when IO M bar is 0, see M bar, IO M bar slash M bar is 0, correct? Now when we say M bar, 0 gets converted into 1, means which is to be activated? Memory is to be activated. So that location will be written for memory. Now when S1 is 0 and S0 is 1, it means write operation. So how microprocessor will come to know that it is IO or it is memory will be done with, if IO bar is low means memory. When S1 is low or S0 is high, then it is write. When IO bar is 0, that is a memory. But now instead of S0, S0 is not there, S1 is there. It means that it is a read. Now if IO bar is 1, it means what I want? M bar, 1 bar, that is 0. So I want memory 0, IO is high. So I will say the operation is for IO. And now if it is 1, S0 is 1, then write, and S1 is 1, then read. So see the combination. This one is the combination. Depending on this S1 and S0, if S0 is there, then write, and S1 is there, then read. So with all these three combinations, the operation of 8085 can be decided whether it is memory read, memory write, IO read, or IO write. Then interrupt acknowledgement. If all is 1, then it is a interrupt acknowledgement. And when it is 0 and both are 1, then it is a opcode fetch. We will see in detail what is the meaning of this opcode fetch in coming session. So this is all about today's session, friends. We have completed the brief and the details about the pin diagram in this session. So thanks for joining this session. In next session, we are going to complete the internal block diagram of 8085. Thanks for joining the session. Do you have any queries? Please let me know. I will clear it in the next session. Otherwise, thanks for everyone. Have a nice day. Let's meet in the another session. Thank you. I am disconnecting the meeting. Thanks a lot.